So let's begin. So last couple of lectures we have taken a look at the introductory idea of object-oriented programming and the concept behind the .NET framework. So for example, in the last lecture we discussed that anytime you write C# program and you have to pass it through a compiler, right? So does it produce the machine code? Or no? No, it produces what we call the IL code. And the reason they do it is very similar to Java, just like Java produces a bytecode, so that we have a portable system, meaning so that our code can run on any operating system without having to recompile it, right? Okay. So then we also discussed, in order to run this IL code, how does it work? Do we load this IL code into the memory of the computer? No. Okay. In the memory of the computer, we load what is called CLR, Common Language Runtime, which has three main parts to it. For example, the just-in-time compiler. Okay. What's the job of the just-in-time compiler? To take this IL code and convert it to machine code. Okay, the second part of the CLR was garbage collector, and third was runtime safety and error checking environment. Right? Okay, what's the equivalent of CLR in the Java world? JV. Okay, so that's why, as I mentioned, if you know Java, it's very easy to switch to .NET or C#. And if you know C#, you can learn Java within a day. So that's one of the nice things about learning both Java and C#. Both are very important languages, as we've already discussed. Okay. So now we also discussed that when we write programs, okay, we will create some classes of ourselves. Okay, so in the object-oriented world, every code that we write belongs to a class. Okay, for example, if you declared a variable like this, and it does not belong to a class, your code will not compile. Okay, so it has to be inside a class. Okay, whatever class name you give it, right? Okay, so we create some classes. We pick some of the classes from the .NET library. So these are pre-created for us. Okay, what we do is we reference the class from the .NET library. Okay, so the terminology that we use whenever we need to pick a class from the pre-created library, the terminology is called reference. Okay, so for example, if you are using Visual Studio, you created some class, for example, and now you wanted one more class from this library. So you will go to the project, you'll right-click on it, and you will say Add Reference. And then you will pick whatever library you are interested in. It will already be pre-compiled. So these are often referred to as DLLs. So you'll pick the DLL, and then you will automatically get the class that you need to use in your project. So gradually you will learn that, right? So anyway, we pick some classes from the .NET library, create some classes of ourselves, then we pass it through a compiler. And just like we discussed, this will create IL code, and then the CLR will read it, convert to the machine code, and then the CPU directly executes the machine code, right? So that's the execution environment under .NET, okay? We also discussed that in the last lecture, that the .NET framework, okay, which is basically an environment for creating applications, including the CLR, okay, including the library. So all this environment is referred to as the framework. Okay, so one of the nice things in the .NET framework is that, for example, when .NET was released in 2000 or around year 2000, the framework version was 1.0, right? So then a couple of years later, around 2001, 2002 time frame, they improved the framework. They called it Framework 1.1. With every framework, there's a separate CLR. So separate CLR with each framework. And every couple of years, they keep improving it, keep introducing new frameworks, okay? So for example, around 2004 time frame, it was framework version 2.0. Okay, so this is again the framework version. Okay, then around 2006-07 time frame, it was framework 3.5. 2008-09 time frame, framework 4.0. Anyway, the latest, which is 2015, is framework 4.6. Okay, so if you have to create anything new, you should use the latest framework. Okay, and once again, with every framework, there's a separate CLR. Okay, so one of the nice things about the .NET environment as compared to Java, even though they've now included it in Java, is that multiple CLRs can exist in the memory at the same time. So there could be a CLR for framework 2.0 as an example. There could be CLR for framework 4.6 as an example. There could be CLR for framework 3, so on. They can exist simultaneously. So for example, if you created some code over here, so you created some code, and some of the classes it's using are coming from this framework library. Okay. Now your code needs to call into some of the classes which were developed earlier, older version. Okay. You can easily do that without having to do anything special. It will automatically know which framework, and because they are residing in the memory at the same time, the versioning becomes automatic, okay? As opposed to Java, where only one JVM exists in the memory, so either you target JVM or JDK 1.4 or 1.5, okay? So that's one of the advantages. And because from the very beginning they designed it this way. So another benefit is every few years they keep improving the language, okay? So for example, over here, this was C# 1.0 as an example, right? Then C# 2.0 over here, okay? This one is C# 5.0 is the latest that we are using, okay? And with every improvement, every new framework, they keep adding more and more features to the C# language. So gradually I'll introduce those features, okay? So again, as compared to Java, where changes do not occur for another 5 years or so. Okay, here changes keep occurring, and they don't have to worry about backward compatibility because multiple frameworks can exist in the memory at the same time. Okay, so anyway, so that was the big picture. Another small comment was that, as I mentioned, there are over 100 different languages, programming languages, that we can program under the .NET. Okay? And all these languages share the same library. So it doesn't matter whether you program in C# or you program in Python or you program in C++ or any other language, you are using the exact same library. Okay? So then the question is, why should we learn C#? You know, if you already know C++, why not learn Python? If it doesn't matter what language we use, okay? And the answer is, as you will discover as I keep going, C#, because it keeps evolving every couple of years, it keeps adding new features. In my opinion, C# is the most, I should say, expressive or elegant, or however you want to put it. So what that means is, in a very small amount of lines of code, you can create something which will take you, for example, 3 times or 5 times the amount of code. Okay, so it's not like you can do something in C# which you cannot do in Java. You can create anything in any programming languages, but how much time do you spend? That's where the difference comes in. C#, because being the newest, usually in a very short amount of time you'll be able to create some very sophisticated applications, right? Okay, so that's the reason we are picking C#. Python, by the way, also is becoming very, very good. Some of you are already taking the Python course. If not, later on, I highly recommend to take the Python course. Then at least you'll feel comfortable. You can program in anything you feel like it, right? So now coming to our learning of C#. First thing we need to do is learn the fundamental object-oriented programming. Then I will move to the intermediate level, and then I'll move to the advanced level. So even though we are going pretty slow, gradually I'll pick up the speed. So coming to basic object-oriented programming, as we discussed, we have 3 key concepts in the basic object-oriented programming. And what are those? Encapsulation, inheritance, and polymorphism. So today, let me try to finish the basic object-oriented programming so that we can start looking at more interesting things. Okay, so encapsulation was basically creating classes. Because remember, once we create a class, let's say some class XYZ, right? We create some variables in it. Okay, sometimes we call these fields, right? And then we also pretend this box is a function. So we also write functions inside a class which have some code in it, right? So which do something useful for us, okay? So as you can see, the class is essentially creating a virtual box, right? Okay. So then we also discussed that, and see, not only we want to learn just the object-oriented programming, we want to learn